G'day, welcome back. Today we're going to be looking at percentiles, how percentiles work with using PDFs to calculate percentiles. And if you sort of remember what a percentile means, like if you say that I'm in the 80th percentile, right? 80th percentile for juggling, right? That means out of all the jugglers in the world, I'm in the top 20%. In other words, I'm better than 80% of the other jugglers in the world. Um, So I hope that makes sense. So higher percentile is better. So if I'm 20th percentile for height, that means I'm really short. I'm only taller than 20% of the rest of the world if I'm 20th percentile in height. So it's 80% of the rest of the world is taller than me. So whenever we're talking about percentiles, so you see in that red box there, the nth percentile. So that if you say that the 80th percentile, P is such that the probability that x is less than that percentile is equal to n over 100. So n being a percent, so it's n over 100. So hopefully that makes sense to you that we're trying to find that's less than. I'll just circle that just so that we're finding the probability that x is less than p. And that will give you the percentage. And so if you remember sort of your normal curves and things like that, you've got a quarter, in each one, 0.25 all throughout the four areas, and if you're looking for the first quartile there, Q1, Q2, Q3. If you're finding that first quartile, then 25% of that data is less than Q1, and that's written down there. Q1, the first or the lower quartile. There's a quarter of the data below it, so that's what we name Q1. If we're trying to find Q2, Q2 is the median. Remember, the median is the 50% mark. And so there's half of the data below it. We call that the 50th percentile. So if you're asked to find the median, you want to solve p is equal to 0.5. If you're trying to find the third quartile, then that's where p is equal to 7.75. Sorry, not p, n is equal to 75. So you're trying to solve where that's equal to 75, etc. So that's how we're finding percentiles. And just a reminder that if you're asked to find interquartile range, the IQR, that's equal to the distance between Q3 and Q1. So Q3 take away Q1. So let's have a question to make it sort of a bit clearer as to what we're doing. Find the IQR for x with the PDF given by that function there. So the PDF is there. Okay, so what we want, firstly, is we want to find out what Q1 is. Okay, so let's do, we need Q1 and we need Q3 to be able to figure out that. Remember Q1? Q1 is the 25th percentile. Okay, so 25th percentile. And so I'm not going to write equals. I'm just going to say I'm figuring it out. So we want the 25th. So we want the probability that x is less than p. So p is the value that we don't know. That's the percentile that we want. Will be equal to 25%. So 25 over 100, another 0.25. Okay, so that tells you the probability that x is less than some number is equal to 0.25, and that will give you, that value of p will give you the first quartile. Okay, and so therefore, I'll go across. Yeah, I'll go downwards, and then I'll do Q3 over here. Okay, so what that means, the probability that x is less than p is the integral. Because it's less than p, it goes from our very left starting spot, our left starting point, our furthest left spot is 0, and we're going to go up to p. So we go from 0 up to p, and we're going to put our function in here, so negative half x plus 1 dx, and that's going to be equal to 0.25. Okay, so we're going to try to find the value of p such that the area under the curve is equal to 0.25, and we'll solve that. I'll just do the working out for Q3. It's very similar. And then we'll go to the calculator. So same thing, we want the probability that x is less than p is equal to, this time, the third quartile, we want 75% of the data to be less than p. Okay, so p is further to the right. We want 75% of the data to the left of it. So it's equal to 0.75. That means that the integral from 0 to p, same function, sorry, I didn't want to reset the board, equals 0.75. We just need to solve both of those and we'll find the value of p. So let's go to our CAS and we'll go menu, algebra, solve, and we're going to solve the integral between 0 and p. My function negative half x, negative half x plus 1 dx. Type that in right. Yep, that's equal to 0.25. We want to solve that for p, and that will give me my p. It's given me two values of p, and we've got 0.26 or 3.7. Which one is it? Well, x is only defined between 0 and 2 for this function. We're only going between 0 and 2. So the value of p must be 0.26, and we want 3 decimal places. So therefore, p is equal to, well, in fact, I'll just say Q1. First quartile is equal to 0.268. Here's my Q1. We'll do Q3. And I'm just going to copy and paste that because it's all the same, except for instead of doing 0.25, it's 0.75. Just check that's all good. Yep, so now doing 0.75, and it's given us the answer of p is equal to 1 or p is equal to 3. Because it must be between 0 and 2, it's equal to 1. Easy. Therefore, the IQR is equal to Q3 minus Q1 equals 1 take away 0.268. Probably could do that in my head, which is 0.732. So that's my interquartile range. If the question asked you for the median, what would you do for the median? Well, that's the 50% mark, where 50% of the data is to the left of p, and so I'll just do 0.5, and so your median would be 0.586. So that's how you find percentiles using the PDF function. Hope that makes sense. I'll see you in the next video.